We have a 10-gram bullet that's fired from a 3-kilogram rifle with a speed of 500 meters per second. What is the recoil speed of the rifle? How much energy does the recoiling rifle put into your shoulder? And if the recoiling rifle comes to a halt in 50 milliseconds, what's the average force that it applies to your shoulder? In this situation, this is an explosion. You have a rifle and a bullet that are one system together, are one piece together, and as you, when the bullet is fired, the bullet flies out one way, and so the rifle will recoil in the opposite direction. Instead of thinking of the forces, the expanding gases push the bullet outwards, and they push the rifle backwards. Instead of considering the external force of either one, we treat it as one system together, and so those are internal forces, and then our momentum is conserved in this situation. So what we want to set up here is that the initial momentum is equal to the final momentum, since the rifle and bullet are a system together, and thus there's no net external forces. Initially, the bullet is not moving, and the rifle is not moving, and so initially the momentum is equal to 0. After the bullet has been fired, the bullet is moving to the right with a velocity of 500 meters per second. It's moving to the right, so it has a positive velocity. What we see here is if we have a positive momentum from the bullet, and the total momentum has to be 0 because it's conserved, there has to be a negative momentum for the rifle. Again, you could put a negative sign here to show that the rifle has to be moving to the left, that the rifle has to have a negative momentum to balance out the bullet's positive momentum. But we're going to just go ahead and leave this as a positive. We'll see that the velocity of the rifle comes out to be a negative number, that it has to be. So the total momentum beforehand is 0 because nothing's moving. The momentum afterwards is the movement of the bullet and the movement of the rifle. We're told that the mass of the bullet is 10 grams, which we'll write in terms of kilograms so that our units come out correctly. The velocity of the bullet is 500 meters per second, and the mass of the rifle is 3 kilograms multiplied by its unknown velocity. From this we can work out that the recoil velocity of the rifle is negative 1.7 meters per second. During the collision, only momentum was conserved. And so when we're talking about the actual firing of the bullet, we could only talk about momentum because momentum is conserved. Kinetic energy is not conserved because there's no kinetic energy at the beginning, but there's a bunch of positive kinetic energy at the end. Basically, in this situation, there's chemical potential energy in the gunpowder that is converted into kinetic energy. So the total energy is conserved, but the kinetic energy is not conserved here. And so now that we've talked about the recoil velocity, the velocity of the rifle after the collision, after the explosion with the bullet, now we can talk about the energy of the system. If you want to talk about the energy that the recoiling rifle imparts on your shoulder, basically that's the work that your shoulder has to do to stop the rifle. Well, whatever energy your shoulder has to absorb is whatever energy the rifle has right now. And if the rifle is recoiling, the rifle has energy that is kinetic energy. We know that the mass of the rifle is 3 kilograms and its velocity is 1.7 meters per second. And so the rifle has 4.2 joules of energy that your shoulder has to absorb. when we're given the time of this change in motion, and we want to find the average force, what we should think about in that situation is that the change in momentum is the impulse, which is the average force times the amount of time of that collision. So basically, the rifle is recoiling. It has a certain amount of momentum. If your shoulder stops it, you are applying an average force over a short amount of time, and that is what is affecting this change in momentum. So we look at the final momentum minus the initial momentum. The final momentum would be 0 because the rifle comes to a rest after pushing against your shoulder. The initial momentum would be the mass of the rifle multiplied by the velocity of the rifle, and we have to keep in mind that it's a negative velocity. It's going to the left. And that would equal the average force times the change in time, which is 50 milliseconds. In this case, we can cancel out the negative signs. And the average amount of force that we get here is about 100 newtons. That average force is approximately 10 kilograms. It's like having a weight of 10 kilograms pushing on your shoulder is what it feels like when you have a rifle butt against your shoulder and you're taking that recoil from the rifle.